7 interstellar travelers are heading toward our planet. A scenario that seems straight out of science fiction, yet it's unfolding for real. Come late 2025, no fewer than 7 substantial comets will swarm into the inner solar system over a mere 6-month window. Such an event is extraordinarily uncommon. Major monitoring programs like Pan-STARRS and ATLAS have yet to record anything remotely similar. Among this group lurks 3I/Atlas, just the third interstellar comet we've ever spotted. With its unusual composition and expansive emerald halo, it stands out as the wildest unknown in this cosmic lineup. The probability of this lineup occurring randomly? Under 0.5% in any given decade. Pure celestial fluke, or a sign that the heavens are defying their own patterns. The explanations and potential dangers begin right now. Night after night, a quiet array of computerized sentinels patrols the heavens. These represent the planet's robotic comet spotters, Pan-STARRS, ATLAS, and their counterparts. Positioned atop isolated peaks in locales such as Hawaii, Chile, and South Africa, these observatories methodically sweep almost the full celestial dome, picking up subtle glows that even the keenest human eye would miss. Their detectors can pick out targets dim as magnitude 21, far less luminous than Pluto ever looks from our vantage. Every snapshot forms a vast tapestry of countless stars and distant galaxies, but the key giveaway is motion. A lone pixel shifting between exposures reveals a fresh comet's arrival. The hunt never lets up. Systems like Pan-STARRS and ATLAS refresh their coverage of the majority of the sky every 2 or 3 evenings. Their algorithms cross-check fresh photos with a vast digital archive of the universe, highlighting any anomalies in position. When a potential find emerges, a cascade kicks off. Instant notifications, swift observations from global scopes, and a scramble to verify the sighting amid the clutter. This tech-driven watchfulness has revolutionized the field. 2 decades back, unearthing a comet required endless vigilant stargazing and some fortune. Today, detections have roughly doubled annually. Previously overlooked dim and remote intruders now get recorded, monitored, and dissected on the spot. The Minor Planet Center documents every find, amassing a swelling inventory of frozen drifters that expands by hundreds yearly. Even with all this capability, top-tier surveys seldom snag more than a handful of vivid comets in one observing period. The bunched arrival of 7 notable ones in late 2025 stretches these setups to their brink. Staff who typically let the software handle things autonomously are now riveted to screens, as incoming signals flood the processing streams with comet pings beyond anyone's wildest forecasts. For the first time, the tech is barely managing to match the pace of the cosmos. Before plunging into this stellar congestion, a handy primer is in order. Comet studies involve specialized jargon, though much of it proves simpler than expected. Perihelion refers to a comet's nearest pass by the sun, the spot where solar rays kickstart the spectacle, vaporizing the icy core into a dazzling cloud of vapor and particles. It features in all comet predictions because that's where the drama peaks. Solar system scales balloon quickly, so experts rely on the astronomical unit, AU, for brevity. 1 AU equals the Earth-Sun separation, roughly 93 million miles or 150 million kilometers. A perihelion at 0.25 Australian dollars places the comet 1/4 of the way between the Sun and us. For amateur astronomers, proximity boosts the chances of a striking visual show. On visibility, the magnitude system rules the day. The secret? Dimmer objects carry higher values. Magnitude 6 marks the threshold for naked eye viewing in pristine conditions for most folks. Magnitude 2 or 3. That's vivid enough to snag glances from casual observers at twilight. Occasionally, with favorable breaks, comets can eclipse even the most radiant stars. Tails deserve a mention too. As comets draw near the sun, each sprouts at least one, occasionally a pair. The dust tail spreads wide and ghostly, composed of fine particles nudged by solar radiation. The ion tail stretches taut and bluish, formed from ionized gases herded by the solar wind, like a cosmic indicator for solar activity. Now and then, a flare from the sun severs this tail entirely, only for it to reform swiftly. These tail-severing incidents are infrequent, But with the inner system teeming in 2025, cameras might capture several in action. Hold on to these fundamentals. They'll unlock every news blurb, celestial map, and twist from these 7 arrivals. Data crunchers poring over comet tracking records often quip that the cosmos doles out shocks sparingly. Over a standard half-year, you'd anticipate just 2 or 3 comets vivid enough for home scopes. The others fade into obscurity, bound for the Minor Planet Center's files. Yet late 2025 upends that script entirely. 7 major comets, their perihelions crammed into one compact semester, have triggered warning signals in every computer simulation crafted by experts modeling comet populations. This scenario pops up. The figures paint a compelling picture. During the past 10 years, advanced digital scans have dramatically boosted our ability to spot dim comets. Still, despite cutting-edge tools, the models indicate that 7 in a single year qualifies as a major statistical rarity. When scientists input actual detection capabilities and comet population projections into their calculations, the typical forecast hovers around 2 or 3 within any 6-month period. The probability of 7 drops below 0.5%. Certain simulations even peg the likelihood of such a vivid cluster at roughly 1 in a millennium. This scarcity goes beyond improved imaging tech or sharper algorithms. The visibility of brilliant comets hinges on orbital mechanics and the unpredictable timing of their solar approaches. While enhanced surveys uncover more subtle drifters, they can't summon a full set of prominent guests. The 2025 array diverges sharply from patterns recorded in the computerized age, and even historical plate images rarely reveal parallels. For analysts crunching the data, anomalies like this warrant deeper scrutiny. Could this signal echoes from a far-off impact, quirks in Oort cloud behavior, or a stellar alignment so improbable it seems almost arranged? Regardless of the reason, the stats speak volumes. The 2025 comet congestion represents the nearest thing to hitting the jackpot in heavenly observations that contemporary stargazing has witnessed. Certain comets glide through our solar neighborhood with barely a trace. Their subtle shine fades into the stellar backdrop. Of the 7 arrivals in 2025, a pair fits this understated profile: C/2022 Pan-STARRS and 240P/NEAT. Pan-STARRS hits its closest solar point on July 31st, sweeping in at roughly $3.82, far past Mars and nearer to Jupiter's path. So remote, the sun's rays scarcely agitate its frozen shell. Consequently, it develops a subdued envelope, detectable solely via scopes equipped with keen sensors. Typical home viewers might glimpse only a hazy patch on the most pristine evenings. Meanwhile, 240P/NEAT, a periodic return, reaches perihelion on December 19th at $2.12. That's double Earth's solar distance, reflected in its subdued luster. Having traversed this route previously, it delivers another subdued performance for enthusiasts pursuing it amid the chilly skies. For these bodies, the primary followers consist of committed hobbyists, recording sightings, merging exposures, and sharing insights digitally. Their diligence completes the tally of subdued entrants, guaranteeing that even the most subdued travelers get noted. Though these 2 won't dominate the view, they highlight the range across the 2025 roster. Spanning subtle telescope targets to attention-stealing stars, they pave the way for the more vivid and theatrical debuts ahead. To those who've gazed skyward yearning for a comet rivaling the constellations, the latter half of 2025 delivers far beyond a slim possibility. Among the septet, 3 stand out as genuine showstoppers: Swan, Atlas K1, and Lemon, each promising its unique flair. Swan, formerly C/2025 R2, makes its nearest Earth encounter on October 21st, zipping by at a mere $0.25, or around 37 million kilometers. Near enough for solar winds to sculpt an impressive tail, it's poised to shine brightly sufficient for unaided eyes at daybreak among relaxed observers. Projections from outgassing analyses suggest Swan might hit magnitude 2 or 3, transforming comet spotting into a communal backyard affair. Shortly after, Atlas K1 charges forward, attaining perihelion on October 8th deep within Mercury's realm. The fierce solar glare at 0.33 Australian dollars should supercharge its outbursts, propelling vigorous streams of vapor and particles. Observers anticipate an expansive tail and erratic surges ideal for striking images in the news. Following that, Lemon, or C/2025A6, draws near on November 8th at slightly more than 0.5 Australian dollars from the sun. Estimates indicate it may glow to magnitude 4, or perhaps 3.5, rendering it discernible in the evening from northern latitudes and perfect for simple binocular hunts. These comets each infuse distinct excitement. Swan's intimate flyby, Atlas K1's solar proximity pyrotechnics, and Lemon's traditional twilight spectacle, all delivering a glimpse of the extraordinary. A comet vivid enough to thrill without optical aid. Not all 2025 comets shine best from terrestrial viewpoints. Take 414p/stereo, for instance, too elusive for casual scopes, yet ideally positioned for sun-orbiting probes. On September 27th, it arcs to just beyond 0.5 Australian dollars sunward, nearer than Venus. However, its path positions it amid solar brilliance from our perspective. Here, observatories like SOHO and Stereo step in, their instruments, built to track solar flares, snapping comets as luminous dashes amid the sun's halo, re-unveiling aspects of behaviors that Earthbound watchers completely overlook. Teams running missions for NASA and ESA are busy coordinating timelines, deciding which icy wanderers merit the limited attention from their instruments. Come October, the heavens will buzz not only with these comets, but also with competing research agendas. C/2024 S1, Swan, and C/2024 G3, Atlas K1, are set to deliver stunning tail formations, whereas the interstellar interloper 2I/2024 Q1, Atlas, arriving from beyond our system, calls for intense examination during its fleeting visit. Every probe operates with a restricted sight line and must fix on a single object at once, forcing hard decisions. Prioritize the unusual interstellar makeup of 2I/Atlas, or pursue the changing dynamics of Swan and Atlas K1 as they react to bursts from the sun. Instruments like heliospheric imagers and coronagraphs will monitor tail separation incidents live, seizing the instant a solar outburst disconnects a comet's ion stream. Such data goes far beyond spectacle. It shows how solar magnetism shapes comet appendages and, more broadly, the unseen atmospheric conditions permeating our solar neighborhood. Come 2025, orbiting craft and terrestrial scopes will link up as a unified array, each tackling perspectives the others miss, guaranteeing no celestial guest evades analysis. With 7 comets crammed into one tight time frame, from late July to December, the solar system's core transforms into a bustling interstellar highway. The opener, C/2024 R1, Pan-STARRS, swings by remotely in July, hardly registering on sensors. Soon after, things heat up. Swan approaches by September, trailed soon by 414p/Stairwalked, which grazes the sun as probes jockey for optimal positions. October gets packed. Atlas K1 plunges sunward, venting gases wildly within Mercury's path. Shortly thereafter, the oddball interstellar 2I/Atlas carves its hyperbolic route near Mars, its envelope ballooning to hundreds of thousands of kilometers wide. November brings C/2024 T1, Lemon, easing into evening views with potential for unaided visibility. Wrapping up in December is 240p/Neat, a subdued finale for lingering observers. Plotted against a calendar, these debuts seem less haphazard and more like an orchestrated signal. Perihelion dates cluster within mere weeks, offering scant breaks for stargazers or experts. The jammed itinerary sparks concurrent viewing efforts, overloaded info flows, and a constant influx of new visuals. For once, spotting a comet isn't the issue. It's distinguishing which one you're observing. This condensed half-year window converts the cosmos into an active testbed, where the interplay of envelopes, tails, and solar gusts unfolds instantly, occasionally framing several comets together. The scene is primed for a run of appendage mechanics and solar theatrics, unprecedented in living memory. Every entrant in the 2025 roster contributes a distinct trait to the evening display, yet none captivates like the dual streams extending rearward. The contrast boils down to the materials in motion and the drivers behind it. The dust trail spreads wide and arcs gracefully, composed of fine particles dislodged from the nucleus by solar radiation pressure alone. These minuscule bits diffuse light across the spectrum, lending the dust trail a faint, occasionally amber sheen that may extend tens of millions of kilometers. It billows softly astern, tracing the orbital bend like a glowing trail. By contrast, the Ion Trail cuts a slim, rigid line in electric azure. It emerges as solar UV radiation ionizes gases in the head, creating charged atoms. The solar wind, a flux of energized particles surging from the sun, seizes these ions and propels them radially outward, regardless of the comet's trajectory. Thus, the trail invariably aligns directly anti-sunward from the core, typically with crisper borders and brighter hues than its dusty counterpart. To observers with the naked eye, the signs are straightforward. Dust trails appear expansive, diffuse, and typically pale yellow or ivory. Ion trails look slender, linear, and cobalt. Each conveys unique insights into the interacting forces, and both yield to solar whims. During a flare-up from the sun, the Ion Trail might detach abruptly, a phenomenon underscoring the volatile, wild nature of these stellar transients. Solar outbursts don't merely ignite polar lights. They can transform a comet's elegant appendage into a chaotic arena. As a robust coronal mass ejection, or CME, barrels across the near-solar realm, it hauls the sun's magnetic lines in tow. Should a comet lie in its path, the spectacle can dazzle. That Ion Trail, the rigid azure spike aimed sunward, may snap off in moments. Far from a leisurely dimming or gradual fraying, it's an instant severing. 1 second it spans millions of kilometers, the next it's detached and floating free as the comet regenerates another. The classic case unfolded in April 2007, when NASA's stereo probes documented Comet Encke's dramatic disconnection. A massive setback struck Comet Encke. A coronal mass ejection, CME, collided with its ion tail, severing it right before our eyes. The video clip turned into a prime example, featured repeatedly in solar physics workshops and among comet enthusiast groups. Experts refer to these incidents as magnetic reconnection events. It's an abrupt reshaping of the magnetic field lines that pulls the tail's ions out of position. For several hours, the comet stands vulnerable, its tailless form serving as a stark indicator of the sun's hidden influence. As 7 comets pack the ecliptic toward the end of 2025, the chances of witnessing another tail detachment live are higher than usual. Solar physicists and backyard stargazers are staying vigilant, scanning for the classic indicators: a sharp bend, a rupture, or a faint trail lingering in the void. Every occurrence provides an up-close view of the sun's expansive effects. It underscores that space weather is no mere concept. It's etched into the heavens as it unfolds. Stories of comets go beyond stunning visuals. They act as immediate updates on solar conditions. Why? It's all about positioning. During late 2025, the majority of these 7 comets follow routes near the solar system's ecliptic plane, that thin disk where Earth and the planets travel. Sharing this pathway boosts the risk dramatically when the sun fires off a CME, putting comets squarely in the path of potential hits. Purely a question of lineup. With numerous comets bunched up along the ecliptic, each lingers longer in the path of solar outbursts. Simulations from solar physicists highlight the data plainly. In an average year, a prominent comet faces roughly a 10 to 20% likelihood of an observable tail severance near perihelion. But with 7 aligned on parallel orbits, those probabilities surge. On average, the 2025 period might yield multiple such detachments, possibly even 2 or more within a single week. For skywatchers, this translates to far more than a busy celestial scene. Each CME sweeping the inner solar system becomes a gamble. Should the alignment sync perfectly, the sun's magnetic forces will cut through a comet's ion tail, triggering an abrupt split, a clear signal that space weather has made impact. Given the optimal setups for so many comets, The upcoming period offers an uncommon opportunity to observe the sun's unseen forces in action, painted in azure trails at sunrise and sunset. Data pouring in from the globe's premier observatories is mind-blowing. Teams employing the Hubble Space Telescope and the James Webb Space Telescope have gauged the coma of 3R/Atlas, the luminous shell of gas and dust encasing it, at close to 700,000 kilometers in width. No mistake there. This one comet's coma spans almost half the Sun's width and exceeds Jupiter's by over 50 times. Photos reveal a hazy green orb that overshadows the solid core at its center, a minuscule speck engulfed in a haze capable of enveloping entire worlds. Yet scale tells just half the tale. What really distinguishes 3I/TLAS is its vigor. When solar rays hit the surface, bursts of gas and dust burst from the nucleus with incredible power. Data from JWST and Earthbound facilities estimate dust release at 6 kilograms per second for tiny particles, equivalent to a bowling ball's mass per second, and as much as 60 kilograms per second for bigger pieces. These streams sculpt broad fans and ribbons within the coma, often evolving from one hour to the next as fresh openings activate and seal with the core's spin. This creates a dynamic, evolving form, perpetually molded by solar energy and cosmic conditions. Researchers at Gemini South and Palomar Observatory have logged endless evenings monitoring these shifts, layering images to extract fine nuances in the streams. Their efforts uncover a comet far from motionless. The streams shimmer and throb, at times forming curves spanning hundreds of thousands of kilometers. Every surge injects new substance into the coma, sustaining the tails that trail extensively astern. Even beyond 1 astronomical unit from the Sun, 3/2/Atlas delivers a performance matching the most dynamic comets on record. The sheer magnitude of this cosmic body defies easy comprehension. For scientists, it's a precious window to examine comet dynamics live with cutting-edge tools. Each fresh photo or stream assessment builds the mosaic further, setting up the subsequent major inquiry. Precisely what composes this interstellar guest? What unfolds when a comet from beyond our system unveils an unforeseen makeup? Analysts laboring non-stop via JWST and SPHX have determined that 3I/Atlas defies norms. Contrary to typical comets dominated by water vapor, this one's coma brims with carbon dioxide. The figures are undeniable. For each water molecule, 8 CO2 appear, an 8:1 proportion that shatters previous benchmarks for any examined comet. The standard pattern for a vivid comet dictates that water ice leads, sublimating under sunlight to craft the signature radiant tail. But in 3I/ATLS, water plays a minor role. CO2 takes command instead. Geysers burst forth from the comet's nucleus, tinting its hazy envelope with a vivid green hue and igniting discussions among astronomers specializing in solar system bodies. Did this visitor originate in the icy outskirts far from its parent sun, where CO2 could solidify in large quantities? Or does a rugged outer shell conceal reservoirs of frozen water, poised to erupt at the perfect trigger? The mystery lingers as research groups scrutinize spectral data to uncover the facts. This composition goes beyond mere scholarly interest. Should 3I/Atlas be ejecting dust laden with carbon dioxide, the remnants it disperses might differ dramatically from terrestrial samples. And an intriguing development looms ahead. Computer models of its path indicate that post-perihelion, the debris path of this extrastellar wanderer could align with Earth's trajectory around mid-2026. Specialists in meteors are already charting potential crossover points, outlining strategies for radar observations and aerial missions to snag just one speck of authentic interstellar material as it incinerates in our skies. Success here would yield the inaugural unaltered specimen from a distant stellar forge, an opportunity to examine pristine isotopes and compounds unmarred by our solar neighborhood's past. At present, each fresh glimpse of 3I/Atlas serves as an entry pass to the cutting edge of astronomical discovery, where the implications could reshape our grasp of extraterrestrial compositions outside our sun's domain. Speculation races ahead of these celestial streakers. As the 2025 comet lineup approaches, online feeds buzz with alerts, sensational assertions, and a nonstop barrage of apocalyptic forecasts. Yet the evidence tells a different story. All comets in this year's display adhere to precisely plotted routes, computed and refined by expert sky watchers with access to massive observatories and the Minor Planet Center's worldwide repository. Not one veers near enough to Earth's path, much less threatens contact. Comet Swan's nearest pass places it roughly 37 million kilometers distant, over 90 times farther than our lunar separation. The others swing even wider, their courses curving smoothly past the Sun under gravitational pull alone. Review boards from NASA, ESA, and various academic outfits have vetted the trajectories, assessed any orbital disruptions, and shared results in freely available publications. Their conclusion rings consistent. No natural process allows this grouping to spark seismic shifts, tempests, or the calamities circulating digitally. Gravitational forces operate as reliably as ever. These are frozen relics, not interstellar battering rams. Their sole likely effect? Boosting the crowds gazing skyward at daybreak and twilight. The takeaway is straightforward. This spectacle is an uncommon delight, not a danger. Embrace it with curiosity, free of fear. If you're keen to spot a comet firsthand, start by pinpointing the ideal spot and timing. Venture out on October 21st right before dawn, and you could witness the highlight. That day, Comet Swan reaches its minimum distance from us, at about 37 million kilometers. Clear views under dark conditions mean no optics needed. Just scan the eastern sky near the horizon. Aim eastward and slightly upward as the sun rises. Should forecasts prove accurate, Swan might gleam at magnitude 2 or 3, matching top-tier stars in brilliance. Its tail, sculpted by solar particles, could span a wide swath overhead, a special sight for early risers. A bit further on, evenings claim the focus. Between November 6th and 12th, Comet Lemon emerges in the west post-sunset. This one's the quintessential twilight observer. Skip the pre-dawn routine, seek a broad, clear westward panorama. Lemon may hit magnitude 4 or surpass it with heightened outbursts. In countryside darkness, it's naked eye visible. Urban light might call for binoculars to discern the nebulous shimmer low on the skyline. Optimal viewing hits 30 to 60 minutes after dark, prior to its descent. For either showing, binoculars enhance the scene, unveiling the envelope's gentle radiance and initial tail traces. A modest scope delves deeper, exposing tail patterns and faint hues. Gear isn't essential, though. A chart on paper, a mobile tool, or basic navigation aids direction. Layer up against the chill. Share with a companion, and let your vision adapt. Steadfastness rewards. Comets fluctuate in luminosity night by night, shifting appearances unpredictably. Amid a 12-month pact with aerial wonders, these moments beckon you to partake. No prior know-how needed, just the urge to gaze upward. These grouped comet sightings lack any parallel in more than 100 years of documented records. Experts highlight that although 3I/Atlas's dust path might overlap Earth's orbit in 2026, orbital projections confirm zero collision threat. Still, the puzzle of why so many emerge in a single period eludes explanation based on present population studies, with forecasting models falling short in explaining this surge completely. Indicators suggest an unusual alignment driven by sheer luck alongside enhanced identification techniques. As 2025 and 2026 progress, history will capture far beyond a mere data irregularity. It will reveal a distinctive chance for live monitoring and research advancements, captured in the moment for subsequent review. This